Hi everyone, this is Miss Yoon. Today you're gonna practice how to solve problems involving the horizontal projectile that's fired at an angle. So, as just to recap from yesterday's video, you guys learned that when something's fired at an angle, there's going to be the components that are going to be divided into two-dimensional. So one's the x-axis, which is the horizontal component, and the y-axis is going to be the vertical component. And whenever the velocity actually, if you look at the velocity at each of these points in the parabola, it's going for the vertical component, which is the y direction, it's going to change constantly, okay, as it travels towards the top. And at top, it's going to be at rest for the instantaneous time, so that velocity is going to be 0 meters per second. As it comes back down, the velocity is going to increase, and that's where that blue line actually, you can see that the magnitude actually goes up. The acceleration for the y direction is always going to be negative 9.81 meters per second squared. That's acceleration, or g. Sometimes you would see that written as g, gravity. So for the x direction, which is the horizontal direction, we have to remember that the velocity is always going to be the same no matter where in the position of the parabola you are at. Okay, so just remember that. And so looking at some of the questions here, I'm going to go over one question that's really long, which has 3 components, A, B, and C, and then you're going to be on your own working on question 2, 3, and 4. Alright, so question says, a small missile is fired with a velocity of 300 meters per second at an angle of 30 degrees above the ground. So I'm just going to draw as I read this, okay? So this is the ground, and it's 30 degrees from the ground, and something is fired at 300 meters per second, okay? After a total flight time of this many seconds, the time total that it takes to hit the ground again is 30.6 seconds. The missile returns to the ground. Okay, neglect air resistance. A, it says calculate the initial horizontal component of the velocity and the vertical component of the velocity. So what this is asking is for you to get the horizontal velocity, Vx, right here, as well as the Vy, okay, which is right there. Okay, so if I were to kind of like redraw this, then it's gonna look something like this, where, you know, this is the hypotenuse of the right triangle, and this is the Vx, and this is the Vy, and we know the angle theta as 30 degrees. And whenever we have the right triangle, we can use the SOHCAHTOA, okay? So in this case, in order for me to get Vx first, okay, I know that I'm gonna use the angle and the sides that are given. So there's always that one side that's missing. In this case, it's the adjacent side, and the hypotenuse is given to us, so we can use the cosine. So cosine of 30 degrees is equal to Vx over 300. Okay. All right, so now in order for me to get Vx by itself, I'm just going to move that 300 over to the other side, so it becomes 300 times cosine of 30 degrees. And if you plug this into your calculator, it comes out to be 260 meters per second. Okay, so that's your Vx. Okay. Now, in order for me to get Vy, there's 300 and this is 30 degrees. I know that this is the opposite, the Vy component is the opposite of that 30 degrees. So it's opposite, and that 300 is the hypotenuse. So in this case, I know that I have to use a sine. So sine of 30 degrees is equal to Vy over 300. Okay? So now I have to just move this over. So 300 times sine of 30 degrees is equal to Vy. In this case, that's equal to, if you plug that into your calculator, it's 150 meters per second. So we got the horizontal, initial horizontal component and the vertical component. Okay? So there we go. Moving on to the second question. So it says calculate the maximum height of the missile above the ground. So maximum height after you fire it is going to be right in the center right there, halfway in the air. Okay, so we want to calculate distance. That's vertical, so that's going to be y. That's what we're looking for. All right, so I'm just going to write down everything that we know about the y component. Okay, so in this case, I know that Vy initially was from the first problem, 150 meters per second. So 150 meters per second is what you know. And time, we know from the problem that it took 30.6 seconds for total. Okay. However, in order for this to be halfway there, I have to divide it by 2. And this is 15.3 seconds. That's a time. And the, let's see. And V, I guess if you think about it, this is the initial velocity, and Vy of the final is going to be at that top point. What do we say about that velocity? It's 0, okay? So I'm gonna write that here. V final is going to be 0 meters per second, okay? All right, now going back to like the equations on your reference table. For the kinematics equations, you can use V, average velocity is equal to d over t. There are multiple things that you can use. You can use V, d is equal to, distance is equal to Vi times t plus half at squared. Or you can use Vf squared equals Vi squared plus 2ad to get distance. Okay, so whatever works for you, you can just pick and choose, and you're going to get the same answer. For this one, I'm going to use this equation, V average velocity equals d distance over time. But we have to look at that velocity, average velocity. So as you can see, the velocity changes. So whenever the velocity changes and you're trying to get the average velocity, I don't know if you remember from a while ago, it's the formula that you have to use is Vi initial velocity plus V final divided by 2. This is not on your reference table, so you should memorize this. So whenever there's a change in the velocity or the speed changes, and you're trying to get the average velocity, you're using this. All right, so in this case, we can use 0 plus 150, right? Or vice versa, over 2, which is equal to 75 meters per second. So that's going to be your average velocity. So 75 equals distance over time, which is, in this case, we know it's half of what's given to you, so it's 15.3, and you just multiply those two numbers together, and the distance comes out to be 1150 meters. If you plug these into any of these two equations, it's gonna give you the same answer. All right, part C. Calculate the total horizontal range of the missile. So in this case, it's asking for you to calculate this distance right here, distance of that total range of the missile. Okay, horizontal range. I'm gonna write down whatever information I know about the horizontal side. So Vx is from part A, I know that it was 260 meters per second, so I'm just gonna write that down. 260 meters per second, and this thing never changes. Horizontally, the velocity is always the same wherever you are. And time, the total time is 30.6 seconds, and we're looking for dx, okay? So I'm just gonna use that equation, d over t, okay? And velocity, because it doesn't change, I can just use that. And we're looking for that d, and 30.6, you just multiply, and distance comes out to be 7,960 meters if you plug that into your calculator, and that's that. Okay, so these are the type of problems that you will be seeing for the horizontal projectile fired at an angle. Okay, so here is the second problem that you can try. You can pause the video, you can try it on your own, and let me know if you have any questions. I'm gonna post the answer key with the step-by-step stuff, like post it on Google Classroom as a separate attachment. Okay, so pause your video here and try number 2. Here's the third question. You can try it on your own, pause the video, and you can check the answer key later. And here's question number 4, the last question. You can pause the video and check back at your answers. Okay? All right, guys.